Welcome back, geometers. Just for the record, I have only like 3 things in this world I hate. I'm going to tell you 2 of them. One of them, Naruto. I think it's awful. Second one, Demon Hunter. Cool. They're awful.
No, Demon Slayer, she likes Demon
Ah, Demon Slayer.
K-pop Demon Hunters. That's a good one.
Yeah.
Okay, I've heard that. Heard that. There's music or something associated with it that's popular right now, but not my thing. All right, 1.3. We have 2 main ideas, and we're going to see them both right now, and we'll treat them like we'll deal with them as we go. 2 big things. We're going to be talking about midpoints, which maybe we've already done a problem with the midpoint, and distance. Now, love me some distance problems, love me some midpoint problems. It takes a little bit of practice, but we're going to be able to make sense of it. I don't think you'll have homework over the weekend. I'll try, but I don't think we will. Okay, so right off the bat, I'm going to sneak this in. The first thing we're talking about is a midpoint. I'm going to define it. And if it's going to be a definition, how do I write it?
All caps.
All caps. Midpoint. Okay. How would you define a midpoint? You can't just say the middle. Give me like 3 or 4 more words.
center of an area.
So, in the middle of what? In the middle of a segment. Okay, you said area. I don't like throwing area in there yet. We're focusing on a segment right now. Does it make sense to have a midpoint of an angle? Not really. Like you can have a ray that cuts it in half, but you can't really have just a point on it. Okay, so when we define this, you guys are right. It's a point that is the same distance from both endpoints. More specifically, we can say the point, and we get a new word I don't know if you've ever heard. The point, and I'm just going to say on segment AB, and we're just saying this segment exists. It could be CD. I don't care what the segment's called. I'm using AB. That is equidistant. Have you guys heard that word before? Okay, using your powers of deduction. What does equidistant mean?
Equal distance.
Equal distance. Boom. Look at that. The point on AB that is equidistant from A and B. This is my and, it's not a plus. Boom. Now, this is all we really need for the midpoint, but there are a few other interpretations of this that we could have. I'm going to sketch an AB down below. Have you guys ever seen EG in a textbook?
Yes.
Or a teacher use it?
Yeah.
Other than me? I've never had, you obviously haven't seen me use it. Have I? Do you guys know what it stands for? Okay, it is not a true example. EG and IE are 2 things that you'll see really regularly. EG, they're both Latin. Exempli gratia, it means for example. Like, here's an example of the concept, not a problem to solve, but here's like us highlighting it. IE is id est, in essence. Like, here's the basic idea of it. So, in other words, is an IE. But let's deal with an EG, so a small example of this concept. I'm going to name this point A and this point B. Holler loudly when I get to where you would like me to place what we'll call the midpoint. Okay, I heard one person who was closer. Here-ish? We're going to work on that yelling thing. By default, I typically call the midpoint M. Yeah, no, Michelle's the only one who's done that well twice today. Everybody else is slacking. Cool, that's M. Does it look like a midpoint? If M is the midpoint, it means that AM and MB have the same distance, right? Or alternatively, you could say that the segments AM and MB are something.
Congruent.
Congruent. Cool. This all mean the same thing. Now, we just saw a second ago for a horizontal line or a vertical line, either way would work nicely. The midpoint is just the what? You said it, Sonny, a second ago.
Yeah.
Is it the mean?
Middle.
Mean. The mean. Give me another word for mean. Average. So check this out. For horizontal, which is horizontal the x or the y-axis? So I'll just put this x, or vertical, which is which axis? Y. segments. It's the average. I'm going to use a shorthand for average. Tell me if this is reasonable. AVG. Okay, what is AVG short for? Average. What? Okay, average. Now, what's awesome about this is it turns out we don't have to go very far to make the diagonal lines turn easy. Just to really highlight this, in the x direction, notice it's not like a really formal symbol. If I have 2 points, x1 and x2, their average would be x1 plus x2, and then what happens to it? Careful, don't get stuck with slope. All I need is the average. Add, count, divide. 2. Right between 8 and 10 is 9, right? 8 plus 10 is 18 divided by 2? 9. Yeah, it checks out. Okay, we could do this for y as well. If you don't want to have it in your notes, that doesn't bother me. If I want to write the same statement in the x or the y direction, what would change? y1 plus y2 over 2. Okay, language-wise, y1 is not the correct way to say this phrase. Anybody know the right way to say it?
The y triangle, right?
Not triangle. We're not there yet. You're trying to do slope. No delta needed. Sub. You might have heard x of. It's not of, it's sub. Like a submarine is under the water. That is a subscript. I like calling them x1, but just so you know, you will hear me say x sub 1, x sub 2. I'm using the word sub, like submarine. Okay, here's how we do it. We already did this once, right? Check it out, though. Should we do one more example on a vertical line?
Yes.
Okay, if you want to do this in your notes, you can, but if you just want to think it out, I'm fine with it. If we have an example, I'm not even going to label it. Let's say that here is the number, I don't know, what number? 4. And this number is 61. I want you to find me where the midpoint is. Cool. A little bit of margin work, scratch work somewhere. Find me the midpoint. If you have no idea what to do with this vertical line, let me know. Talk with your neighbors. I'm going to walk around. How do I find the midpoint here in the y direction since it's a vertical line?
Combine 61 and 4 and then divide by 2.
Okay, so if I just check this, 61 plus 4 divided by 2, 32.5?
Yes.
Okay, alternatively, just because some groups thought about this and logically it makes total sense. How long is this segment?
65.
Ooh, I don't think so.
53, 57.
57. Why? How'd I get it?
61 minus 4.
The difference between them. Now, if you want to go the red logic, you can. You're going to do it slower, but it's equally valid. If this is 57, what's half of that? 28.5 is half of it. Now, if I want to go 28.5 away, I can start here and go up 28.5, which if you do 4 plus 28.5, you get what? You get 32.5, or you could start at 61 and subtract 28.5. Both of those methods work. Would you rather do it in 1 step or 2 steps?
1.
Let's use the averages. Cool. Now, rather than just giving you the formula, which a lot of you guys see the formula already, but we're going to actually do what's called a derive. Not drive, but derive. Do you know what it means to derive something? To take apart or to figure out how it works, to come up with it yourselves. Okay, I want you guys to tell me any theorem you've ever learned. Can you name another one? There's lots of other ones. A theorem. Okay, there are a lot of theorems out there. We're going to get a lot of them this year. But everybody knows the Pythagorean theorem. A squared plus b squared equals?
C squared.
What type of triangle?
Right triangle.
Does it go the other direction? If I give you a right triangle, is it true that it will be a squared plus b squared equals c squared? Both directions are true. Yep. Okay, we're going to do a little bit of deriving. So, let's check this out. Let's derive, and not crazy mathy, but let's derive the midpoint formula. Check it out. I haven't told you, but what do you think that crazy combination of consonants means? It's a midpoint, right? There's my shorthand. Derive midpoint formula. Okay, we've already seen it in the x and the y direction. It's easy, yeah? Maybe. Here's what I want us to do. We are going to work in real general. And if I say stuff that doesn't make sense, when should you tell me that? Right away. Is there ever any reason to be embarrassed in here?
No.
If I ask a question and somebody says that's a dumb question, like you probably wouldn't say it to me, but you might say it to each other, what happens to the person that says that's a dumb question?
Consequences.
Yeah, there's consequences. I don't put up with it. We're all here to learn. We're all at different levels. That's okay. Cool. First question. What axis is this? Henning, you're not helping. What axis is this? Okay. Could you plot a point? Like, does everybody remember how to plot a point? Notice, I don't have a scale or anything, so it doesn't matter. I'm going to put 2 arbitrary points. Arbitrary meaning doesn't matter where I put them. I'm going to put one up here for fun. Anybody know what numbers that should be?
Like 3, it's like 8, 2.
I mean, you could say it's 2, 3. You could say it's 2, 8. The numbers don't matter. I know that y probably is bigger unless my scale is wonky. Without saying it, do you agree that this point is just x1, comma, y1? Like there's some xy pair there. I'm going to now put another point here. If x sub 1, y sub 1 was the first point, anybody have a reasonable guess?
X2.
X sub 2 and
X2.
y sub 2. Now, I stress the sub because I literally took like 4 or 5 math classes before I realized that this statement was read differently than this. My teacher always said f of x, x of 1. I thought he said the same thing every time, and I never understood it. X sub 1, f of x. They're different phrases. If you've never seen that or thought about it, hopefully you never have to. Okay, this midpoint problem, equally easy or a little harder? It's a bit harder, I think. Now, it doesn't have to be. When we look at this, I think that I can reasonably argue that probably in here is about the midpoint, right? I'm going to label this point x sub m. What do you think my m represents? The midpoint. Okay. Subscripts, we're working really general. I could have given you numbers, and I will give you numbers, but I want to think about this. This midpoint, could you find it right now without any direction, do you think? Maybe some of you could. If you used your book, I would say most of you could. But without looking at the book, maybe a couple, maybe. Here's the deal. This is a diagonal all of a sudden. Vertical lines are easy to count. Horizontal lines are easy to count. Diagonals are a little harder, unless we think about something. Every ordered pair, even these two, they're made of 2 parts or components. Every ordered pair ever has 2 components. What are they? X and Y. Which means that diagonal line that we see, does it travel some distance x? Does it travel some distance y? Let's just deal with the x direction and the y direction separately so that it's easy. Check this out. Could you find me, hypothetically, if I dropped a line straight down, could you tell me this ordered pair based on everything else in the room or on the board? Here's my challenge. Do it. Talk with your neighbors. Write lightly so if you're wrong, we can fix it. Find me the coordinate of this ordered pair right here. I'm forming a right triangle just so you know. I want that coordinate or that point. About 60 seconds. We'll come back together. I don't think it'll take that long. If you don't know what to do, ask this guy. All right. Check it out. We're going to come back together because this might be the most abstract thing you've ever had to do in a math class. Abstract meaning like just kind of out there. There's no physical representation of it. If I was at x1, hypothetically, and don't write the numbers, but we'll use numbers here. Maybe, just maybe, this was 2, 8. I don't want you to write the numbers. This might be what, 5?
20.
Couldn't be 20 if this is 8. Couldn't be 10 if this is 8.
12. 2.
Couldn't be 12. It could be 2. Why couldn't it be any of those other ones?
Because it's too big. Yes,
It's lower than 8, right? Okay, check it out. I'm at x equals 2 right here, yeah? If I drop straight down, what x value am I still at?
2.
Okay. Everybody cool with that? If I'm at x equals 2 and I go straight down, I'm still at x equals 2. But I wasn't at 2. I was at, what was the x coordinate? X sub 1. Okay. Here, I'm at 2. If I make a horizontal line, am I still at 2 right now? and right now, in here, I would still be at 2. But I wasn't at 2, I was at y sub 2. I can make a new ordered pair as long as I drop straight down and straight horizontal. With numbers, it's a little easier. Everybody okay with that for now? Okay. If you're not, we're going to clean it up right here. When I'm trying to identify this, I think we have a way to calculate it. Even this diagonal line, it traveled some distance x and some distance y. This pair right here has an x coordinate and a y coordinate, right? Here we go. We're going to work this out. All I need to know is that from here, how would you find the average of this x and this x? How do we find the exact middle between those two numbers? How did we say it a second ago? Add them and divide by 2. What are the thems we're adding to find?
X1, Y2.
So careful. X1 plus, we're only doing the x direction right now.
Oh, X2.
X1 plus X2, right? And divided by what?
Y1.
Okay, we'll get there because you're right. You're trying to skip ahead. It's just divided by 2, yeah?
Yeah.
Average is add them up, divide by 2. Klein, in the y direction, how do you find the midpoint between this y value and this y value?
The midpoint?
Yep. Look in your notes, so long as you wrote it down, about probably one line above this. How do we find the midpoint between two numbers if they're vertical or horizontal? Vertical in this case. So if your notes aren't as nice, check it out. Here's how we find the middle between two y points.
Y. Oh, did you just say?
Yeah.
Oh. Oh. Y2, Y1 plus Y2 over 2.
Whoa. Over 2. Okay. When we look at this problem in this view, this part might be kind of ugly. That's okay. That's probably the first time you've seen real general stuff. Do you agree that this is just the middle of the x's and the middle of the y's?
Yes.
If we put them together in a single point, we found the midpoint of a diagonal line. Every time. Just treat it as such. Okay, we will jump in with questions or with examples of this on Tuesday. We don't have school Monday. It's Labor Day or Memorial Day, one of those two.
Labor Day.
I will never remember that. Okay, this weekend, there's no football. Is there anything else going on? Painting this afternoon for parking spots? Cross country race tomorrow? Monday, where? Kelty? Okay. I'm going to have Zeke come yell and cheer for you guys. Sweet. Later, Raiders. What's up? I'm going to go snag a bunch of pinks for dog food. I'm going to go out to Summers Bay. Yeah.